Hi, welcome. This is a lesson on how to solve for a triangle using trigonometry. And solving a triangle means to find all the missing sides and all the missing angles. So let's look at an example here. Number one, we've got triangle ABC. We know that angle B is 44.7, and we know that this opposite big B is little b, and that's 9. And we know that opposite angle C, which is typically the right angle, is little c. And then opposite A is little a. And we can call angle A theta, just so that we have something to hang it on. And so then I can choose which side I want to find. Let's find A. A is the adjacent side, and B is the opposite. So I've got opposite and adjacent. That means I'm going to use the tangent. And so the tangent of 44.7 degrees is equal to the opposite, which is 9, over the adjacent, which is A. And because our variable is down in the denominator, we need to get it up and out of the denominator. So we multiply by A on both sides. And then 9 is equal to A times tangent of 44.7 degrees. And then we want to get the A alone, so we divide by the tangent of 44.7 degrees. And we do that on both sides. Now, I'm going to pause for just a second. I'll be right back. Okay, so at this point, we can these cancel, and we can find the value of A by just taking 9 divided by the tangent of 44.7. So we take 9 divided by the tangent of 44.7 degrees. We don't have to type in the degrees because we know it's in degrees based on how we set the settings of the calculator. And so it's 9.09 rounded to the nearest hundredth. That's 9.A then is approximately equal to 9.09. And so we can record the things that we already knew. B equals 9. Angle B is 44.7 degrees. Angle C is 90 degrees. And now we know that A is approximately 9.09. And C, we could use the Pythagorean theorem, or we can use one of the trig ratios. I'll go ahead and use one of the trig ratios. This time we'll use the opposite, and the C is the hypotenuse. And so we've got the opposite and hypotenuse for the angle 44.7. That's the sine. So the sine of 44.7 degrees is equal to the opposite, 9 over the hypotenuse C. So once again, we're going to multiply through by C. And then C times the sine of 44.7. We're going to divide by the sine of 44.7 on both sides. It cancels it on the left, and C then is approximately equal to 9 divided by the sine, 44.7. And that's 12.79. The 5 rounds it up to 12.80. So we've got 12.80 is our hypotenuse. And for angle A, we're going to use the triangle sum theorem that the sum of the angles of any triangle is 180 degrees. So if I take 44.7 plus, we'll just say A for angle A, plus 90 for the C, that gives us 180. Subtracting 90 gives, from both sides, gives us 44.7 plus A equals 90. And then subtracting 44.7 gives us that A is equal to 90 minus 44.7 is 45.3. And so then we can go to here and say this is 45.3. And that's the first triangle that we have solved. All right, we'll come back here and do the next one here in just a moment. I'm going to pause for a second. All right, welcome back. We've got another triangle here, but they didn't draw the triangle for us. So we want to actually go in and draw the triangle. And there's a triangle. And we need to label it. So C typically is the 90-degree angle. Opposite big C then is little c. And then you can put A and B, whichever you want. It doesn't matter. Here, I'll put A here and B here. And opposite big A is little a, and opposite big B is little b. And we're given that information that little a is 12, so I'm going to record that. There's 12. Little b is 9. And then we want to kind of record what information we know. We know over here that C is 90 degrees. We know that little a is 12. We know that little b is 9. And we don't yet know what C is. So I would say maybe we could use the Pythagorean theorem to find C. A squared plus B squared equals C squared is our Pythagorean theorem, and A is 12, so that's 12 squared plus 9 squared equals C squared. We go to our calculator. 12 squared plus 9 squared gives us 225, and then that would be, so C squared equals 225, and then taking the square root of both sides, C then gives us the square root of 225. Sorry, 225 is 15. Now we know all three sides, and we just need to then find angle A and angle B. Now, I can choose any three of these sides that I want. I'm going to just choose this one and this one. And this is the hypotenuse. And this one is the adjacent. If we're talking about angle A, which we will here, that's angle A is our theta. So then I say I've got A and H, that's cosine. The cosine, and I could put theta or A, I'll just put angle A. The cosine of A is the adjacent, which is 9, over the hypotenuse, which is 15. And if the cosine of A is 9 over 15, A then is the inverse cosine of 9 over 15. And then we just go to the calculator. Second function cosine is the inverse cosine of 9 over 15. And that gives us 53.13. A then is approximately equal to 53.13 degrees. And at this point, we can just use the triangle sum theorem. The sum of those three is equal to 180. And if I take away the 90, then the sum of those two acute angles is 90, which means that if I take 90 minus 53.13, 90 minus 53.13, that gives us 36.87. 36.87 degrees. And that's it. That's what solving a triangle looks like. We've got all of the angles, all of the sides, and we're good.